Yesterday, we took notes on all the different features of exponential functions. So today we are going to review them on this worksheet. So here's how you determine growth and decay. Look at, is it increasing or decreasing? The initial amount is also known as your y-intercept. It's written as a coordinate pair. The horizontal asymptote. It is the number on the y-axis that the function gets closer and closer to without actually crossing. And we're going to highlight those on this paper. Domain, as long as we don't have endpoints, it's all real numbers. If you had two endpoints, then you'd have to change it. The range is determined by the asymptote. So we are going to do number 3 together. So we're going to look growth or decay. So look at the two examples. This is growth. This is decay. So this one is decay. You can write it or you can just circle it. I'm fine with either one. Initial amount is where it starts on the y-axis. That's your y-intercept. So I'm going to put a dot on there. It is right here. That is my initial amount. Yep. So it's a coordinate pair. So you have to put 0, 3. You have to write it as a coordinate pair. Then the horizontal asymptote is where it doesn't ever cross. It gets closer and closer to without ever actually crossing. It's like the fence. So this is kind of different from the other ones. See how the other ones, you can clearly see the line where it doesn't cross. This one isn't so clear because of the window. So this one, I'm going to go ahead and just tell you it's at 0. So go ahead and highlight where y equals 0. And that's going to be our horizontal asymptote. So it's going to be at y equals whatever number it is on the y-axis. Remember, this is our y-axis. It's at 0. So it's the horizontal line that the graph will not cross. Our domain is left and right. These have arrows going left and right, so it's all real numbers. Then our range, it's going to be determined by your asymptote. So look back over here. It says set of all y values. Identify the asymptote, which we highlighted. Determine if the function is above or below. The function is above. I'm going to write here above. So since it's above, I'm going to use this. Y is greater than the horizontal asymptote. So y is greater than 0. If it was below, then you would say y is less than whatever value that is. Okay, so this will be your assignment to do. One more thing that we're going to do today is this tables and graphs paper. Go ahead and fold this to the center. Y'all are going to spend some time graphing. Whenever you fold this one, make sure you can see the bottom where it says asymptote. Just to the center, folding it toward the center, or you're on a different line, paper. It should look like this. This is where we're going to need our calculator. Remember, these are exponential functions. So the x is exponent. Don't put 3x. Put 3 to the power of x. Put 1/3 to the power of x. So go to clear out your memory. Second plus 712 on your calculator. I'm going to put this in. So go to y equals. We can put this in two different ways. We can put it in as y equals parentheses 1/3 to the x, like that. You have to put in parentheses though. Or you can put it in y equals the fraction 1/3. I'm going to show you both. So go ahead and put in y1. And then the other way is to do alpha y equals, to put it in as the fraction, as the pretty text is what it's called, or something like that. 1/3 raised to the x. So remember, the exponent is an x. It's not 1/3 times x. So put these in into your calculator right now. Yep. Go ahead and put both of them. Did you get the first one? Okay. Second one, you do alpha y equals alpha y equals and choose number one. This is numerator over denominator. Mhm. So we're doing both of them so you see how they put the answers on the table. All right. So we're going to do second table. Look at the table. All right, let's fill in the table. So we got to go up to -2. So these are the exact same. It's just different ways of writing it. So -2 is at 9. -1 is at 3. 0 is at 1. 1 is at 0.333 or 1/3. See how these are the exact same thing? So it's just the way that we put in the equation determines how it's listed in the table. I'm going to write these as decimal, so 0.33 repeating, which is also 1/3. And then number 2 is 0.1 repeating. So it's going to get closer and closer to 0 without ever crossing it. That's our asymptote. We can push graph to look at the graph too. So that's what it's going to look like. We're going to graph the points and then connect them to make a smooth curve. So -2. So we're going to go over to -2 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 3, 0, 1. That's your initial amount, your y-intercept. And then 0.3 repeating. So over 1 and 0.3, so that's less than a half. And then 0.1 repeating. It's never going to cross this line because if you look at it here, see how it just kind of blends into where the x-axis is? That's your asymptote. All right, so go ahead and connect your dots. And put arrows on the end. Make it kind of a smooth curve. And highlight your asymptote. Your x-axis on this one. Yep, it's at 0. So we can go ahead and fill in the asymptote y equals 0. That's where it's at. The y-intercept is your initial amount. So where does it start? 0, 1, yeah. We're going to write it as a coordinate pair 0, 1. Domain, it goes on and on forever, so it's all real numbers. And it's always going to be all real numbers unless there are two endpoints. But these have arrows at the end, so there's no endpoints. Therefore, it's always all real numbers. The range, it's going to be y is something 0. So is this above or below 0? So go ahead and write above. What inequality represents above? Less than or greater than? Greater than. So go ahead and put greater than. That's all you have to do on these. So your assignment for today is to complete this, turn it in, and then do all this graphing and tables. And that's all you got to do.